is that like the horizon is at an angle I don't expect it to be when you're in a 737. And so we were diving and banking radically. And then we hit a certain altitude and leveled out. And so it was just like he needed to get beneath the cloud deck in this one hole where he could get beneath the cloud deck. And he had all heavy items banished for most of the flight, and the stewardesses confined to their seats.
And so once he got down to that altitude, then things settled out and it was a smooth landing for the rest of it?
No, we definitely landed at like a good 15-degree angle with the sudden straighten at the end, and we came in hot. We used the whole damn runway to stop.
Wow.
Yeah.
That's crazy.
Yeah, it was. We did things that I'm thinking the pilot's having a blast, but 737s don't normally do these things when they're full of passengers.
Yeah.
The pilot was totally professional. It was all handled beautifully. Yeah. Nonetheless, there was a great deal of, yes, your luggage is going to fall out on top of your head now.
You might want to expect a little chop on this flight. Yeah, they're always so calm. My flight was mostly uneventful coming back from Las Vegas. Let's see. This is a show. We're going to do this. I want to remind everybody that you'll hear me say your name. So all you have to do is just say hi in the chat, and then in a few minutes I will say hello to everybody. Cool. So where were you coming back from?
I was out for a board meeting of the Astronomical Society of the Pacific, and as soon as the meeting was over, I met up with Phoenix and Rux, who you know, and we attempted to recreate one of the Anthony Bourdain layover itineraries, only in part. So Anthony Bourdain will do layovers in different cities and then do a tour de force of different eateries and alcohol establishments. And I don't know how that man is still alive. I just don't, because we only went to 3 locations, followed by, like, the Uber driver actually said, hey, do you want me to drop you off at this pancake joint on the way taking us back to the hotel? Because we clearly needed pancakes. But yeah, I don't know how Anthony Bourdain does it. We tried to like recreate his legit. No.
Okay. Let's see. I'm going to say hi to Dave Regan, David Swenson, Giselle Sabarin, Graham Ash, Guido Bibra, Harry Patrick, Helga Björkhog, John S., Johnny Zed, Leonard Lindstrom, Nancy Graziano, Orju, Psychocat 740, Richard Strassel, Thomas Tranick, Tom Nathy, Tom Van Scotter, Tony Lynch, Tori Godwa, and Valdegast, and William Vandebeek. So just before we get on with the actual show part, if you want to see more Fraser Cain, I'm going to be the guest on Cord Killers today at 7 o'clock. That's with 7 p.m. Eastern, 4 p.m. Pacific. That's going to be with, of course, Brian Brushwood and Tom Merritt. And we're going to be talking about Canadian cord cutting. So, and how we don't get any shows in Canada at all. No Hulu, no Amazon Prime, no Spotify, no Pandora, no. So,
VPN just doesn't cut it, does it?
And in fact, Netflix is now, so sometimes some people would use a VPN to go to different countries, to pretend to be in different countries so they could watch their Netflix. And now Netflix is cracking down on that, I'm told. And so now you just have to watch your Canadian Netflix, it's just not great. We get a few more BBC things that I think the Americans do. We get a few shows that the Americans don't, but apart from that, it's mostly a lot crappier. So,
well, and the irony is that like a ton of the good US shows are filmed in Vancouver, and then you can't watch them.
And then we can't watch them. Yeah, exactly. Okay, cool. So if you are wondering what this is that you have stumbled into, this is Astronomy Cast. We were podcasting before podcasting was cool.
It's true. We were.
Episode 410. We're going to talk about Planet 9 today, which is perfect. Perfect timing. Although we didn't get Mike Brown on Fridays.
I heard
because he was hanging out.
he
Yeah, it was
got
too
sucked
bad.
into a meeting.
Yeah, which was too bad because
Have to
he's such a
reschedule.
treat. Yeah, to talk to. But so I don't have the information right from the horse's mouth, but I think you've done your research, so you'll know what to say.
And
Oh.
we went from radically cloudy to radically not. So there we go. Now
Okay.
I think my lighting looks less horrible. It looks horrible in a different way.
Okay. Well, whenever you're ready, I'm ready to press record.
It's picking up the wrong mic. Hold on. That mic. Use that one. Okay. I am pressing record. It is recording.
I have also pressed record. It is also recording. Here we go. Astronomy Cast, episode 410, Planet 9, Facts and Fiction. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Great. Done for like 3 weeks of travel. Looking forward to kind of getting my life back in order. I still, once again, I have no idea how you travel so much without just everything falling apart. I just can't. I can't do it.
I can generally work on airplanes as long as the airplanes are not vibrating so hard that it's impossible to focus on my device. I had that last night, but next week I fly off to the Czech Republic and I'll be at the Academic Film Festival of Olomouc. But other than that, I'm mostly home until May.
So good. I'm mostly home until the beginning of June, and there's an astronomy festival happening in New Mexico that I'm going to be speaking at. So
that's awesome.
Which I'll give you more information as we get closer to it. Okay, great. Let's see. So the discovery of Planet 9 has caused a wonderful, confusing uproar and a flood of misinformation in the news and social media. So we'll sort out what we actually know, what things just aren't true, and what things might be possible. Now, when we started Astronomy Cast so many years ago, our first episode was about how we lost a planet.
It was, yes. We lost Pluto thanks to Michael Brown.
Thanks to Michael Brown. But Mike Brown taketh, but Mike Brown also giveth. And so here we are, lo these many years later, and Mike Brown and team have potentially delivered us a new planet, Planet 9, which needs a new name. But I guess it won't get a new name until it actually gets discovered. And this is the part that's kind of weird, right? People are really a little confused. Does this thing exist? Does this thing not exist? Does this have anything to do with Nibiru? Are the conspiracy nut jobs right? Should I not be defending, science anymore? It's a topsy-turvy world. So Pamela, first, let's go back and sort of talk about like what has actually been discovered so far.
So what has been observationally determined? These are things that you can point a telescope at the sky, point the telescope at a few more places in the sky, and after looking at all of these different places in the sky, go, okay, that chunk of ice is acting in this weird way. This chunk of ice is acting in this weird way. And when you start putting together all of the weird things that we're seeing, they can all be explained by one roughly 10 Earth mass object that is on a highly elliptical orbit, tilted to the plane of the rest of the solar system, and hanging out, yanking things around.
And so we're seeing objects move in their orbits in ways that you would not predict, based on the calculations, look at the gravity, try and figure out where it should be moving in its orbit. And these things are all, and a bunch of these objects are all just a little askew from where they're supposed to be. And so they are inferring that this object exists, not that they've actually observed it yet.
And it's not just a few chunks of ice misbehaving. So first of all, we do see a variety of different Kuiper belt objects that have highly elongated orbits that are all kind of pointing in the same way out of the solar system. So they all come in closest to the sun on roughly the same side of the solar system, and then they stick out at a weird angle out the other side of the solar system. So you have this family of Kuiper Belt objects that are in aligned orbits pointed in the same way. Then we also have Sedna, this giant chunk of ice in the outer solar system, not quite as big as Pluto, but pretty big, with a highly elongated orbit. And it actually is also totally explained by this object. And then we also find that there are what we call centaurs, these families of things orbiting in small clouds that would have resonance pockets where their orbits are stable, and then the rest of the orbit would be cleared out. So you have these clouds of objects predicted by the theorized orbit of Planet 9. And when we look, we find those centaurs. Okay, that's kind of awesome. And then there's other things with unusual orbits that just seem to make sense. And so when you can explain so many different observable things by a single object with very predictable attributes, you start to think that thing probably exists. And when you look at the predictions they've made for Planet 9, they're extremely precise. They're able to say what its orbit likely is in terms of how it's tilted relative to the rest of the solar system. They're able to say what is the variation with nice error bars for its orbital distance from the sun. They can say even what is its theorized brightness, and given that brightness, would we have seen it already? So there's a whole bunch of beautifully aligned stuff that tell us the bugger is probably out there and currently sitting in front of the Milky Way, refusing to be detected.
Right. So let's get on to that second part, which is like, why haven't they found it? I mean, do they know where it is, roughly where it is, or specifically where it is?
They know what its orbit would be. We don't have sufficient data to say, based on how things are orbiting, to say exactly where in that orbit it would be. But if you look at the WISE satellites survey of the sky and start saying, okay, where can we rule out using WISE data that there would have been things here, there, this other place? You look at that part of the sky and WISE doesn't see anything. So using WISE, you can say it's probably not on its closest approach to the sun. It's not at 200 AU. It's got to be further out. Okay, fine. So we used WISE. Then what other data is out there? And we have the Catalina Sky Survey, which is year after year working to map out all of the asteroids that are potentially hazardous to us here on Earth. But the data they use to try and detect all of those asteroids can be reprocessed to try and recover slowly moving objects in the outer solar system. And this is something that Mike Brown and collaborators did, going through, and they didn't just do it to try and look for Planet 9, but they also said, okay, let's take a blind look at all of this data from the Catalina Sky Surveys, and they called this the Serendipitous All-Sky Survey. And looking at it blind, they recovered all of the Kuiper Belt objects in those parts of the sky at those magnitudes that we would have expected to find, except for one that was hanging out in front of the Milky Way, refusing to be seen against all of the background objects. So they know that this technique works. They know they can look at this data, they can recover objects, and they know down to what magnitude they can recover objects. And they believe that it's down to about 19.1 V magnitude in the north and 18.6 in the south. And so that tells us that this is a faint sucker, but it's still something that you could recover with a good 30-inch telescope.
A good 30-inch that we've all got kicking around.
Well, but this means that you don't have to be using the VLT. You don't have to be using one of the hardest to get times on telescopes in the world. You need a good standard university telescope. A lot of universities have these in a dome somewhere on their campus.
Right. But it's about knowing where to point the telescope
So
to really catch it.
So using Catalina, they ruled out a whole chunk of the sky. Now, Catalina didn't allow them to rule out the entire sky. So they also looked at the Pan-STARRS transit survey, the Pan-STARRS moving object survey. That got them fainter. So
They
here,
tried.
They
really
tried.
tried.
So now they've gotten down to about 22.5 magnitudes. And this is where you're really starting to go, I need a multimeter telescope now. Please give me a bigger telescope. So they ruled it out, except annoyingly for that part of the sky that probably, means it's hiding in the Milky Way. So it turns out that this sucker, and there's amazing plots that help understand just how bad the situation is. It is probably out beyond 600 AU right now. It is probably at a visual V magnitude of 22nd magnitude or fainter. And it is probably, because it's so far out, moving so slowly, less than 0.2 of an arc second per hour, which most stars, when you look at them with a good sight, will be 1 arc second across. So to get the planet to move 5 diameters of what it would appear like, you're looking at like 5 times 5, 25 hours just to get it to move a couple of diameters. And that's not going to be something you can detect easily.
Right. So you're going to need a world-class telescope, one of the big guns. And you're going to need to know precisely where to point it so that you're going to get the resolution. And then you're going to have to leave that thing collecting light for hours to be able to get a pretty good, observation of this object moving
they don't have to be contiguous hours. So you can look at it, come back.
Sure. But that's what you're looking at what you're going to need. And so this is just one of those things that they just don't have. Like there's just all those telescopes are busy, and no one's going to give up space in the big guns just to examine the sky 1 arc second at a time.
And it's a pretty big chunk of the sky that it's predicted to be in. So while we can say it's over there somewhere is still several tens of degrees, and that's not the whole sky, but yeah, it's a bit difficult.
So you got into some of the facts about what we know. You talked about, we know it's about 600 AU. What's that? That's like Pluto's like 100 AU-ish?
No, it's not that far out. It's in the 20s, I believe.
Okay.
So we're looking,
much further than Pluto.
Yeah, okay. This is a very distant system. And it's just not the kind of thing that we're used to dealing with, even thinking about. And this is starting to trigger some interesting rumors floating around the internet.
Right. Okay. Well, we'll get on to the rumors then. So what are some of the rumors that people are proposing is going on here?
One of my favorites is, I love how people don't know how to use units sometimes. People are trying to say that the every 20 to 30 million year extinction cycles, which we do kind of sort of see here on Earth, are caused by Planet 9. Now, the problem with this is that estimates on the orbital time for this new planet are on the scale of 20 20,000 years, which means any cycle that we'd be looking for should be a 20,000-year cycle. And people are now trying to blame a 20 million year cycle on the object. And million and thousand are not the same thing. If they were, my bank account would be better.
Right. So this idea of like, it's the nemesis theory, right? That there is something out there, and it's not like there's anything wrong with the nemesis theory itself, right? This idea that there is like a brown dwarf or maybe some kind of red dwarf that the sun is actually a binary star. It has this binary companion, and this object moves into, closer into the solar system every 20 million years, 30 million years, and lets out a cascade of objects, interactions from the Oort cloud, throws comets, moves the asteroid belts around a little bit, and causes some damage. And it is super interesting that the mass extinctions do seem to happen on this fairly regular interval. This is absolutely science.
Yeah.
So, but
not
as you said,
related science.
Yeah. So there's nothing wrong with the nemesis theory, just that Planet 9 wouldn't account for the nemesis interval.
And I do want to make a correction. I was fact checking while we go. Pluto is about 40 AUs away. So we're looking at Pluto, 39.44 AUs. This object we're looking at currently, it's around 600 AUs. So huge difference in distance.
Right. What else are some theories that are coming around on what we're looking at here?
So one of the things that's happening is people are striving to read as much into every physics paper as they can. And there were some scientists who were working quite hard to try and figure out, is there any way we can narrow down on where this sucker is in its orbit using any data that we have, any of it. And one of the ideas that was put forward was, if we had enough data from the Cassini space probe that would, as it orbits Saturn, give us more precise information on Saturn's orbit, maybe that would help us learn more about where Planet 9 is, because Planet 9 would be plugging away, pulling on Saturn gravitationally, creating small anomalies that we may not be able to see from the planet Earth, but we might be able to detect given the fullness of time in Cassini's orbital data. And somehow between that research paper and the internet, it became, there are anomalies in Cassini's orbit that no one had heard of before. There are anomalies that have been observed in Cassini's orbit, and they tell us exactly where Planet 9 is. No. And poor NASA had to actually come out with a press release saying, no, there are no anomalies in Cassini's orbit. And if we were able to keep the spacecraft orbiting till 2020, then we might have enough information on Saturn's orbit that has been refined thanks to Cassini that we might know something. But, Cassini's almost out of fuel, so we're crashing it in 2017. And so we don't get to do this. And we're really sorry. But really, there's no anomalies in Cassini's orbit. And it's just one of those press releases that you read it, and I'm like, wow, someone had a really bad day. Because you can just imagine some orbital person is being like, you never told us there were anomalies. And the person's like, there aren't anomalies. No, there aren't anomalies in Cassini's orbit.
Okay, so then let's talk about the big elephant in the room, which is this idea of Nibiru, right? Which you and I and Phil Plait have been debunking this thing since, I'm not kidding you, 1997, I think, is when Phil Plait was starting to write articles about how this is not a thing.
Yeah.
And are like showing pictures from their camera, and they show two suns and like, see, the planet's on its way.
Yeah, no.
And so, could there be a planet careening towards Earth in the center of the solar system that's
No.
on a really long elliptical orbit, and we just haven't seen it, and it's on its way? Maybe,
But
but it
it's
would
not
have to
this
be.
one.
But it's not this one, because once again, we can see Pluto, which is as you said, 40 astronomical units away, and it's teeny tiny, and it's not very bright, and we can detect it with big telescopes. So anything that would be coming our way that would interact with us or impact us in any way would need to be a very powerful telescope. It would be very bright in the sky. We would be able to see it, and we just don't see it. Mike Brown, one of the best astronomers in the world, can't find it. He's found all the others. He can't find this one yet.
And the thing about the theorized Nibiru is, first of all, it gets us back to that 27 million year orbit, because they like to use it to explain mass extinctions. This we know would have a tens of thousands of year orbit. So orbital time doesn't work. The other thing is, people are like, is it going to kill us next month? Well, think about how long it took Pluto to get visited by New Horizons. We launched that spacecraft when Pluto was still a planet. And it was traveling really expletive fast for a solar system object. And if you think about how long it takes for comets that get detected out by Jupiter to make it into the inner solar system, if something was going to wipe us out next month, we'd see that sucker, and it would be like way closer than even Mars is by now.
Yeah, absolutely. So
no,
again, Nemesis, perfectly reasonable theory. A planet that gets close to the inner solar system, it's possible. Although, you would wonder why all of the rest of the solar system wasn't all messed up from this planet coming by every few thousand years. But the point is that it would be detectable, and it just isn't. So there goes that theory. So were there any other sort of nutty theories that you think need to be squashed?
It wasn't a nutty theory so much as an intriguing Twitter exchange. So this weekend, poor innocent Mike Brown ended up having to stick his head in and say, no, Planet 9 is not going to destroy the Earth. And I believe it was either Ian O'Neill or Dr. Matthew Francis. They're both doctors, but their Twitter accounts, it's Astro Engine or Dr. M.R. Francis. And I don't remember which of the two it was, said, what I want to know is if Planet 9 is going to destroy Pluto. And Mike Brown basically responded, we're working to figure that out because I want to know that too. So it sounds like there's some interesting outer solar system dynamic calculations going on to figure out what is the long-term perturbations that this object is going to cause. What are the long-time bad things that it might trigger by throwing different icy bodies around over the fullness of time. We're not talking
over billions of years.
Yeah.
Right.
So yeah, it's I follow Pluto Killer, Astro Engine, and Dr. M.R. Francis. They all have these great exchanges on a fairly regular basis.
Right. And so I guess the point here is that, when we look at Pluto, it has this really strange elliptical inclined orbit, very different from the rest of the planets. And so one of the possibilities is that Planet 9 helped it get into that weird orbit, and it's going to help it get out of that weird orbit right out of the solar system, maybe way down the road. One thing, this is a little unrelated, right, is that don't astronomers sort of have odds on whether Jupiter will eventually throw Earth out of the solar system? Like, wasn't there... Right?
I think it's been pretty much figured out that isn't going to happen. But looking at the other side of this problem, there have been a few people kicking around the idea that rather than Planet 9 flinging things out of our solar system, maybe our solar system early on ate Planet 9 from another solar system. So perhaps in the earliest days, when our solar system was right butted up against a bunch of other solar systems in that open cluster that we formed in, maybe we just happen to have stolen Planet 9. It's that no one knows even what the probability of that is. Most likely, my thinking, based on not having done a Monte Carlo simulation, is it probably formed here because it actually makes us more normal of a solar system. If you look around, most solar systems have a few oddballs in them, and they have things that are in weird places. We're far too normal. This is why, like, all of our solar system formation models are just not sophisticated enough to deal with the rest of the galaxy. This finally makes us a little bit less explainable and thus more normal.
Helps us fit in. So if we could get out to Planet 9, what would it look like? I mean, you said it's, maybe 10 to 12 times the mass of the Earth. Is it an ice giant? Is it rocky? Is it ice? What is it?
There's actually some really neat work being done where they're actually starting to come out. And this isn't Michael Brown and Konstantin Batygin. This is a different team over in Europe. I believe one of the authors' names is Esther, and I wish I could remember the rest of their names because that's not useful information. Anyways, there's teams that are currently working to model if you had a 10 mass object, and we know 10 mass objects are going to be basically ice giants like Neptune. If we had a 10 Earth mass object in the outer solar system, how would the materials inside it have settled out? And you basically end up with an icy rocky core surrounded by various layers of very cold gas. You're looking at something that was in the mid 200s of degrees Kelvin. It's cold. And potentially quite shiny. That's what we're hoping for. But that's just models. Reality has a tendency to surprise us.
Right. An object that big is going to still have a tremendous amount of heat and pressure in its core, and that's going to go pretty far out into its outer layers and, an atmosphere before it really starts to cool down to that minus 200 degrees, that the upper atmosphere. So, but definitely like gas, like made of like the same stuff as Neptune.
So we're looking at something that's basically 4 times, maybe not quite that big, roughly 4 times the radius of Earth. So yeah, cold.
Let's say we did get a fix on it. We wanted to send a flyby to it. What kind of scale would it take to actually reach out and put an object into just a flyby, like New Horizons?
It's not that it's hard to do. You just need to know its orbit and then be very patient across multiple generations. It's just time. It takes time to get that far out. And if it's at 600 AU, while it probably is on its way back sooner rather than later, it's not moving very fast.
Yeah, I'm just doing the math in my head, right? About 150 years-ish. 100 plus years for sure, depending on how many gravity assists you can get going.
And ion drive would help somewhat because you'd have constant acceleration, but still.
And one of the other kind of really interesting things is that this could just be one of a whole class of objects out there. This is the one that we can kind of detect, but it's entirely possible there's just more of these out there, even bigger ones, just the further out you go.
Well, so mathematically, we have a few different things that point to maybe having some other larger Earth-like sized things out there. So there's a cliff in the Kuiper Belt, as near as we can tell, out around 55 AU. And one way to explain that cliff in the Kuiper Belt, where it's just like suddenly we have no more objects out here. One way to get there is to say, maybe we have an Earth-like object that's resonance is causing things to get knocked out of that particular band of orbits. But mathematically, we're not seeing any evidence for anything other than maybe something that's weeding out the Kuiper Belt at that 55 AU cliff, and then evidence for this. Now, there could be further things out, but you start to run into problems that they're not going to be gravitationally attached all that firmly. So how did they get there, and why did they stay?
Well, so I guess we'll have to wait until Brown and team actually get some photographs of this object before we can come back around and give an update. Everything is still so theoretical right now.
And I am going to make one more correction. We have people pointing out that I made a unit flaw. It's the temperature of this theoretical object would be 47 Kelvin or minus 226 Celsius, not mid 200s Kelvin. That would be death.
Right. That would be.
So thank you for your patience, because this is all new stuff that we're learning as we go. So it's not often that we get new worlds. And so basically it's once every very long lifetime. So the last time this happened was in the early 1900s. Now we're in the early 2000s. So you and I will be dead the next time a planet is found, should history prove itself forward.
Right. And just it's good to know that you are here as the science is getting figured out. It's just like the same thing that we say about dark matter and dark energy. We've got the slightest hint that something is going on, and now the telescopes of the world are turning to try and piece in this puzzle. And it might be that it's a dead end, and it might be that the math was wrong, and it might be that there is a whole new planet out there, and we're within a couple of decades of having some images of it. Of course, we just need to wait for the Large Synoptic Sky Survey, and
Gaia will do this one.
Gaia will do it, okay.
If it's pointed in the right place. But what's so amazing about this is you have Michael Brown and Constantine, who always gets left off of absolutely everything, and we really need to stop doing that. It's Constantine Badigan. I may be mispronouncing it, but you need to remember his name. It's not just Michael Brown on this. They said, hey, we have this notion there's this world out here. Let us show you why we think this. And now scientists all over the world are looking to try and understand all they can as the entire astronomical community goes, well, how do we find this sucker? And that's kind of awesome to watch.
All right. Well, stay tuned. To be continued.
Thanks, Pamela. Continued. Thank you.
Gonna save this.
Yep. Bear with us, everyone, while we deal with the boring part of and now we save part of the show. So for those of you who are doing this for the first time, you're watching us record live a show that will be edited and posted as a podcast. We'd love it if you'd go and subscribe to us in your favorite podcatcher. We are in iTunes. I believe we're also in Spotify.
And this is where we get to the after party.
Yeah.
People were mentioning this in the chat. Like, someone's like, stick around for the after party. And someone
someone who was like, our goal right now is to make them laugh. And I'm like, yes. And this is why I mostly don't read you in real time. I love you all. However,
trying to make us laugh during the show.
Yeah.
No, that's not hard to do.
It's true.
You should aim a little higher. Okay, so go ahead and put any questions that you want into the chat. As you see, there's a little question mark sign that people are using, and that is great because it really helps me see the questions. But I'm going to go up, and you know that the chat. Oh, no, maybe it doesn't. I thought I got cut off, but it looks like it doesn't. How do you get that question mark? So if you click on the triangle set of icons, scroll down, you'll see the little question mark. I guess it's a smiley. It's an emoticon.
So on my Chrome browser, at the very bottom it says say something, and then to the right there's a smiley face next to the three dots. If you click on the smiley face, it brings up the menu of emoticons.
So Nancy Graziano went to NEAF this weekend, and she said it was a lot of fun. So that's a Northeast Astronomy Forum.
Yep.
Yeah, and you often go there, don't you?
I haven't been in a few years, but yeah, I've gone a bunch in the past.
Richard Strassel wants to know: is Planet 9 inhabited by horrible, brain-stealing, flying fungi creatures? If so, is there anything we can do to appease them? Maybe.
Yes, we send them Trump. I don't know. I'm making stuff up. I saw that on the internet. Let's raise money to send Trump to Mars.
Or Planet 9.
Or Planet 9.
Let's see. Oh, MLG Echo says, "Who are these people's credibility, and how long is this show?" So, what's your credibility, Pamela?
I have a doctorate in astronomy and a master's in astronomy from the University of Texas, where I did my PhD in galaxy evolution, working with John Cormandy. My bachelor's of science is in astrophysics from Michigan State University, and I'm currently an assistant research professor at Southern Illinois University, Edwardsville, and I'm the director of the NASA-funded CosmoQuest Virtual Research Facility.
Whoa. And I've been a space science journalist for 17 years, reporting.
And you're the publisher of Universe Today,
and I'm the
which is like
publisher of Universe Today. Yes.
Yeah.
And I went to the Astronomy Academy of Dr. Pamela Gay. If anyone wants to give me that PhD honorary degree, I'll take it. So Nichols of the Yard says, "Is Planet 9 likely to have been created with the other planets, or would it have been a captured wanderer?"
And this is one of the things that we're not sure. It could have formed as part of the rest of the solar system, gotten flung out during the violence that's described by the Nice model. This is where Uranus and Neptune are thought to have started much closer in the solar system, and when Saturn and Jupiter hit a resonance where Jupiter went around twice for every once that Saturn orbited, things just got flung haphazardly throughout our solar system. It's possible that all of these different interactions over time just led to hurling of worlds. Worlds do collide. It's a problem.
Mm-hmm. So, but could it have been captured from another solar system?
It could have been captured by another solar system. This would have needed to happen at probably a point in history when we were in a much denser part of our galaxy. Right now, it's low probability that this kind of event would happen in our modern local area of the galaxy. However, in the early days of our solar system, we were in a dense, what's called an open cluster. This is, if you look at the Pleiades is a fairly undense open cluster. It's been around for a while. It's spread out. Hyades is an even older version. It's spread out even more. So over time, you have a star-forming region like you see in the Sword of Orion with the famous Orion Nebula. Then the stars over time spread out. All of the gas and dust gets converted into stars. But in the earliest days, when those solar systems are forming, they're like snuggled up right next to each other. And you can imagine that perhaps in the early days of the solar system, something theft-wise might have occurred. Young stars stealing from each other. We don't know the probabilities on this yet.
Leonard Lindstrom asks, from British Columbia, my home province, why not use parallax instead of proper motion to detect Planet 9? So I guess what he's getting at is
too far away.
With proper motion, but I mean, you can use parallax to see the motion of stars, the movements of stars, right? So with proper motion, right, you're gonna, that's how you would detect, that's how you see, say, Mars move through the sky at night. While with parallax, but you're going to be waiting while the Earth is on one side of the solar system, on the other solar system.
So the way that you can use parallax, you can actually do this with your eyeballs. Close one eye, hold up your thumb. I'm currently blocking my webcam, and you can see my thumb totally blocks my eyeball. So now I switch which eye I cover, and to me it appears like my thumb jumped sideways relative to my webcam. What you saw is suddenly you could see an eyeball. This jumping of my thumb as appeared as my vision jumps from left eye to right eye is the same thing as if you have two different facilities on different sides of the planet observe, or you wait for the planet to move over time. Well, if you're going to wait for the planet to move over time, the actual proper motion is going to outpace the parallax rather quickly. parallax from one side of the planet to the other side of the planet, however, is going to be far too small to catch Planet 9. So
No, but what
if you're
about
going to have to wait,
waiting 6 months until you're on the other side of the sun?
yeah, the proper motion will have outpaced the parallax. The amount of movement that you see due to proper motion is greater than the amount you see due to parallax.
So it's like, and so then you won't be able to see. You won't know which one is which. You'll just see some movement, maybe.
Yeah.
Yeah, I get it. Okay. Adam Synergy asks, well, could Planet 9 be detected by its micro-lensing effects?
Yeah, but the probabilities of that happening are just way too low. And in general, it works better when the things that you're using for lensing are much further away.
So in theory, though, it is going to transit in front of, it's going to occult a star. And by doing so, it's going to cause the light from that star to get all wibbly wobbly. But you would kind of have to know where it's going to be and when it's going to do it. And then you don't need to find it.
And at 20-second magnitude, it's, in the grand scheme of the universe, fairly bright. There's a ton of stuff brighter than it. I'm totally aware of that. But the likelihood of it occulting something else is fairly low. I mean, if you think about how we observe Pluto, most of the time when we're talking about Pluto occultations, it's because something inside the solar system, an asteroid or something, passes in front of Pluto. There may be cases, but I'm not remembering any off the top of my head, of Pluto passing in front of a background star.
Oh, sure. That's how they get it at its atmosphere and such.
But nonetheless, that's only visible for like part of the planet at a specific moment in time. And the likelihood that we're accidentally going to catch something like that is very low.
David Fairweather asks, could some long period comets be a result of this object interacting with the Oort cloud?
Unknown.
And the Oort cloud is way further out.
Yeah.
Right? Like this object is in the inner solar system compared to the Oort cloud. So it's a whole other sense of scale that you're dealing with here.
But it could be interfering with the Kuiper belt in ways that cause the Kuiper belt to periodically fling things inwards. This is where long-term modeling is needed. Stay tuned.
David Gay says, hi, first time I've caught it live. Any relation?
I have no idea. I do have an uncle with that name. I don't know if that's my uncle with that name because it's a fairly common name, though.
Yeah.
I have no idea.
So Valdegas is talking about how Plato talked about the great year of 36,000 years. Do you know what he's talking about? What Plato was talking about?
I don't.
It's probably the precession of equinoxes, says Valdegas.
Oh, yeah, that makes sense. Yeah, the precession of equinoxes is 26,000 years. Unrelated coincidence.
Margot Robinson asks, would Planet 9 be capable of being terraformed?
No.
Well, how do you
terraform something that doesn't have a surface?
I've done it in my show. We've also terraformed a black hole. No, we didn't. We tried. We also terraformed the sun, but needless to say, it's not a great idea. Yeah, terraform Jupiter. All you have to do is extract all of the gas off of Jupiter. You're left with the rocky pieces. Break up the rocky pieces into small rocky pieces. Move them into different orbits. Then give them nice little atmospheres, et cetera, et cetera. Like it's engineering at an enormous scale. So
yeah, at that point you're not terraforming. You're using Jupiter as raw materials.
Yeah, exactly. There's someone at my door. I got to go grab that. You can grab some more questions.
That is completely random. Okay. So we stopped planning to look at this. Margot Robinson says, could JWST or W first detect Planet 9? I'm pretty sure that JWST could. I don't know the instrument instrument package they have planned for WFIRST. I know they're planning spectroscopes for WFIRST aimed at measuring the redshift of galaxies. I don't know if it has any other instruments planned that would be useful. JWST, it has imaging packages that can observe in the infrared. So just like we were hoping to find Planet 9 using WISE, JWST is going to have a similar high. There's the infrared. All of the planets appear in the infrared capabilities down to much fainter magnitudes. Okay, scrolling. I want to know why everyone's mentioning pancakes. I love pancakes, and now I want more pancakes.
That is a thing that... were you not around for this, Pamela? I said this in an episode of the Weekly Space Hangout. No? The gist is my opinion on how the U.S. Method of human space exploration should go is that they should just build all the parts so that they can then, within a smaller time frame, be able to take on any goal. So they could like go to an asteroid. So they have the right launcher built, they have the right crew capsule built, and they've learned bigger and bigger techniques about keeping people alive in space.
Legos. Yeah,
Legos, right? And so that then when someone, when a president sends that, I want to put a human on an asteroid, and then NASA's ready to go. And so the analogy that I use, I think I like your Lego one better, was that have the stuff ready for pancakes. Like here in my house, I always have the stuff ready for pancakes. If it's time to make pancakes, I can make pancakes. I can also make French toast. I can make all kinds of things. I can make crepes, various breakfasts, because it's just a fairly straightforward connection from what I've got around me. And I think the problem is that when we set these really long-term goals in space exploration, like we're going to go and send a human back to Mars in the next 20 years, it doesn't survive the changes in administration, the changes in, it's not necessarily a realistic goal. You just don't know if it's possible. So that's what I was trying to get at. Yeah. And so the problem is that we always then feel disappointed. Like, we were supposed to be returned. Why did we never return to the moon? Why aren't we, how many times have we been promised sending humans to Mars, or returning to the moon, or visiting an asteroid, or all kinds of things. So that is the reference. Clearly it has become canon here in Astronomy Cast and our other shows. So
Ashwin Herman, sorry about the pronunciation, just wrote Lego pancakes equals waffles, and I now want a waffle iron that makes Lego shaped waffles.
I can also make you some waffles. Yeah. Yeah, Richard Strauss.
There needs to, so there are waffle irons that make Darth Vader and Death Star shaped waffles. We need a waffle iron that makes, like, you can actually build them Lego waffles. Just like little waffle sticks. That's all I need. Just Lego shaped waffle sticks.
See, this is the danger of even having this conversation, is because now we all just start to think about tasty breakfasts.
It's true. It's true. I could eat breakfast food for every single meal, which is why I have to bike ride long distances.
Yeah, exactly. So Nancy Graziano says that after speaking with a ULA representative at NEAF, their long-term rocketry plan is the modular system, something like 24 to 26 different configurations based on payload, which that sounds great. I mean, it's even like the next rover that's going to Mars is going to be based on the Curiosity platform. They're making modifications to the platform, but it's going to be essentially Curiosity, which I think is great, but with different scientific instruments on it. So let's have a third one. Let's have a fourth one. Let's have an eighth one. Let's have, a bunch of deep space probes.
We were really good at that. We have the deep space probes because the Voyager probes were based on the same hardware as prior exploration probes, and then Cassini built on that same hardware line. So we were continually upgrading that hardware line, sort of like the Pentium chip just kept getting upgraded and went all the way back to the old 8086 architecture. We finally went sideways from that, but for a long time we did have all of the same exploration probe family of hardware that you can plug and play your instruments with. We just haven't got there with rockets, and there were plans to get there with rockets, but hasn't happened yet.
Yeah, it's even like when you need to get to another city, right? You can take with an airplane. You like, well, I can fly direct. I can fly via Chicago. Like, have you ever like tried to make a flight work when you're like, I've got to get to that city? What if I go via Calgary?
Yeah.
Oh, yeah, there is a flight. I can get on that flight. Right? We need to have that infrastructure. And so I would much prefer just the efforts were just towards infrastructure, and for NASA's part is just about trying to remove the unknowns. Can we make artificial gravity in space? We don't know. Let's find out. How long, what are the problems with growing plants in space? We don't know. Let's find out. So all those little pieces, and then you can make those available to the private companies, to other space agencies, and eventually we'll become a true spacefaring civilization. But by setting some big goal, trying to allocate tons of money, and then having to cancel it because you've lost support for it, that sucks.
Yeah, everyone just specializes when you say, we're going to do this very difficult thing as quickly as possible. When you do that, you specialize everything the whole way. If you think we're going to build a whole family of things that sequentially build on one another, then you sit down and you're like, I need this function and I need this function. Software, a lot of times the same mistake gets made. You say, I want to create this mammoth monstrosity, so you don't build all the little tiny library functions that make what you do extensible to other projects.
Yeah. And I think we're seeing the lessons learned from the technology industry starting to really be adopted by the space industry, but it has to be the disruptors, right? It's from the SpaceX's and the Blue Origins. By the way, SpaceX landed on a barge.
It's true.
It happened.
It was awesome. And it skittered slightly sideways. And did you hold your breath when it did that? Like, we get emotionally attached to these. So it's coming down, and it straightens out, and it lands, and then it skittered sideways just a little bit. I was like, don't fall over. And then I just kept thinking, it's on a barge. What if it gets hit by a big wave?
I'm amazed at how fast it comes in.
Oh, yeah, yeah.
Like, it comes in really fast, but somehow slows down enough and then lands. But there's no way it was going to stop. And then, nope, it stopped and made it. And then it was there. And so now that they've proven they can do this really hard thing, now they get to go back to doing the much easier thing of landing just on solid ground close to where you took off. So Jason says you should write in Fraser on November 2nd. You can't. I'm Canadian. So I can never be your president. I'm sorry. Nancy Graziano asks, if gravity is the result of mass warping space-time, do you think we'll ever be able to generate or control microscopic black holes in order to create artificial gravity on board space stations?
That actually doesn't work because of the 1/r² way that gravity functions. Gravity falls off as distance squared, and so you can end up with a microscopic black hole with massive amounts of gravity at the subatomic level and negligible gravity a couple centimeters away. And so microscopic black holes just aren't going to solve that problem. This isn't to say that we aren't going to eventually find something more effective than just spinning your spacecraft Babylon 5 style. But so far, physics doesn't allow for anything other than spinning your spacecraft Babylon 5 style.
Yeah. I guess the most useful one would be accelerating your spacecraft at 1G for a year. It just requires an incomprehensible amount of energy. But for
like a space station, you can't do that.
Right. No. But if you're trying to travel to another star, it's really convenient. You want to travel to Alpha Centauri, you accelerate towards Alpha Centauri for a year at 1G. You've got nice, pleasant gravity, and then you turn around and then decelerate at 1G, and you've got nice, pleasant gravity, and you've made a trip to Alpha Centauri in only 2 years. Even better is that you can keep on accelerating for years and years and years and years, maybe for 100 years, and you will have gone billions of light years. You will have experienced hundreds of millions or even billions of years of time thanks to time dilation, and you'll get a chance to see how the universe ends. So, I mean, it's awesome. I love it. So let's get on that.
Yeah, there's not enough like stuff in the universe to fuel that. But okay, we'll try. We'll destroy the whole universe just so you can go really fast and see how it all ends.
Rocket that will take me closer and closer to the speed of light and give me just endless amounts of time dilation.
I want a TARDIS.
You want a TARDIS? Yeah, that'd be great.
I just want to skip through time.
Well, okay, I think we're at the end of our hour. So thanks to everybody for watching this show. Thanks to Pamela, of course, for bringing the brain. A reminder, I will, in about 2 hours, be on Cord Killers, which I think you can see at diamondclub.tv. I think that's where they do it live with Brian Brushwood and Tom Merritt. And we'll be talking about Canadian cord killing, cord cutting, cord
Good
killers.
luck.
Yeah, it'll be fun. All right. Thanks, everyone. And we'll see you all on Friday for the weekly Space Hangout. Anything else coming up this week? Learning Space?
No, this week we are mostly trying to catch up. We're reviewing applications for the jobs that we have open at CosmoQuest and prepping for, like I said, I'll be at the Olomouc Film Festival next week in the Czech Republic, coming home, and I'm hoping to start putting together stuff for our Eclipse 2017 trip. So stay tuned. Check out cosmoquest.org/X, which is our blog, for details on everything as we know them.
All right. Thanks, everyone. We'll see you all later.